Good morning and Happy New Year, everyone. Welcome to the first Spatial Innovation Limited's monthly webinar for 2023. We're glad to have you and look forward to us meeting like this over the coming year. My name is Tanya Manasai. I'm Vice President, Corporate Services Division here at Spatial. And Spatial is the leading geospatial products and solutions distributor in the English-speaking Caribbean. Today's presenter is Lionel Grant, GIS Solutions Specialist at Spatial Innovation Limited. His topic is an introduction to ArcGIS Velocity. So ArcGIS Velocity is a cloud-native add-on capability for ArcGIS Online. Getting started is easy. Secure a license and access it within ArcGIS Online. It enables users to ingest data from the Internet of Things platforms, message brokers, or third-party APIs. It also helps users process, visualize, and analyze real-time data feeds, store those feeds as big data, perform fast queries and analysis. This webinar will focus on how to connect to and fuse your ArcGIS data with data from other sources, push results of analytics, whether performed in real-time or batch mode, as alerts, or publish them as GIS maps and data services for use across your enterprise. These maps and data layers can be used by any ArcGIS application, such as ArcGIS Pro or ArcGIS Insights for additional analysis. You will learn how to use this software as a service IoT application to better leverage your real-time spatial data for essential operation decisions, such as remote monitoring of assets, predictive maintenance, and process optimization. So welcome again, everybody. And over to you, Lionel.
Thanks, Tanya. Thank you so much. I reiterate greetings to all online and once again say thanks for making it to our first webinar for the year 2023, entitled An Introduction to ArcGIS Velocity. As was mentioned, my name is Lionel Grant, and I am the GIS Solutions Specialist within the Customer Empowerment Business Unit at Spatial Innovation Limited, CBU for short. Within this unit, we aim to empower our customers through value-added engagement, ensuring optimization of a customer's investment. The specific roles within our department includes but is not limited to solutions engineering, software maintenance, training, and technical support. Headed by Mr. Roshan Clark, Deputy CEO. Today, we will be starting with a high-level overview of ArcGIS Velocity and the use cases that supports its design. Just an outline of today's presentation, we'll be looking at ArcGIS Velocity, some use cases, real-time visualization and analytics, looking at it as an add-on to ArcGIS Online, and exploring a demo at the same time. Please make use of the question and answer feature as we'll be taking your questions at the end of this presentation. So ArcGIS Velocity. Let us talk about ArcGIS Velocity. In today's world, we know that we are living in a very increasingly connected society. People now have multiple connector devices between home and work computers, mobile phones, smartwatches, just to name a few. But what has been changing recently is the availability of these smart devices and the price at which we are able to afford them to be used and to harvest sensor data from them. from these smart devices, whether for tracking or monitoring purposes, from fleet vehicles to equipment, shipping containers, now work factory and industrial systems, environmental sensors, and more. ArcGIS Velocity is a new capability that extends Esri's geospatial cloud with real-time and big data functionality to address these kinds of use cases. ArcGIS Velocity provides a wide variety of capabilities to ingest and work with sensor data. You could just configure out-of-the-box connectors to bring in data from Internet of Things IoT platforms and third-party APIs. It's also an end-to-end system for analyzing, supporting, and analyzing sensor data in real time or in near real time with scheduling, of course, micro-batching analytics, and also over time, looking at historical data. You can also take immediate action as a result of your analytics. So not just storing data to visualize the results, but send notification or trigger a process in another system. Is a new real-time and big data processing and analysis capability in ArcGIS Online. Simply, it enables you to ingest, 1, 2, visualize, 3, analyze, 4, store, and finally, to act upon data from Internet of Things sensors. Today's discussion will showcase how to connect to streaming data and automatically disseminate information and alert personnel when specified conditions occur. Design analytic models to process high-volume historical data to gain insight into patterns, trends, and anomalies within your big data. So as I mentioned, those sensors are getting smarter. They're getting cheaper. And the means at which we can use them and leverage them and deploy them to explore data from them and harvest for our own use, depending on the variety of use cases that may be represented here. Given that majority of sensor data has a location component, there's a wide variety of geospatial use cases in the Internet of Things. This means that there are increasing numbers of real-time geospatial use cases with at least an increasing number and variety of organizations. Let's discuss a little some of these real-time use cases. Towards the top left on screen is my first example, personal tracking. Personal tracking, one of the more common use cases. Apps on phones and wearable devices can collect location data. And this is critical for ArcGIS Velocity, location data. And organizations are interested in this kind of data to monitor staff location in real time for safety and to ensure assigned work is completed. Secondly, resource optimization. These are the more advanced use cases, for example, where employee tracks are used to uncover opportunities to optimize field operations. This is similar for fleet and asset tracking. So many customers have tracked their fleet with GPS devices for many years, and now sensors are being mounted on valuable equipment to keep track of them. Further, we also have infrastructure protection. When thinking of hazard and threat monitoring, real-time data is integral to this particular use case. So historically, hazard monitoring has primarily been done with weather feeds against critical facilities or infrastructure. Today, however, those feeds are more current, and there are also transportation, social, and crime data feeds available, and organizations want to synchronize all these data feeds. Another key use case is SCADA system integration and operations monitoring. This particular example is for the utilities and natural resource industries, and also in the agriculture and environmental sectors, to include use cases for soil, crops, and air quality monitoring. And there are new forms of real-time sensor data emerging from transportation, like connected cars, that can be used to understand the traffic patterns at the new level of details available. In transportation, there is an increasing number of roadway sensor deployments to bring in data from connected vehicles, and especially local governments are looking to be able to mine this data and understand micro-traffic patterns. We will look at this in a demo momentarily. The use cases are many and varied, but the commonality among them is that in these cases, they require real-time data that is tied to a location. And this increasingly connected world, the speed of data is growing rapidly. ArcGIS Velocity, real-time and big data engine for ArcGIS Online Esri's Geospatial Cloud. To any of these services and to achieve rather these use cases that were mentioned, especially with data at a high rate, you will need to be able to do three fundamental things. Firstly, you need to ingest the data in real time so that you can visualize and interpret it. Secondly, you need to analyze the data continuously to identify incident and store the data over time for historical analysis. Finally, is to alert the right individual or just generally speaking to take action. ArcGIS Velocity is built around those fundamentals as a framework in which those capabilities can be configured as needed for nuances for your own use cases. Now let's explore more what ArcGIS Velocity is. ArcGIS Velocity provides a real-time and big data capability for the ArcGIS cloud across those areas that we mentioned in terms of use cases. First, it includes a variety of connectors for ingesting data, connecting to different sorts of real-time data, handling different data formats, and scaling to satisfy high rates. So as your business model grows, ArcGIS Velocity grows with you. So as sensors are being deployed out in the field, they are increasingly being onboarded and connected up to Internet of Things cloud frameworks like Azure and Amazon Web Services, among others available through data vendor APIs. ArcGIS Velocity can subscribe to or query those kinds of platforms directly without requiring developer level integration. Some persons may be saying, you know, this may involve a lot of coding. No, all of this would have already been done and being built in the system. And what's needed is just a step-by-step workflow that will get you the kind of output that you want. And we'll show you and walk you through how to do that momentarily. You can perform streaming analysis in real time, batched analysis in near real time with scheduling, and also analyze large volumes of data that were collected over time. Also, and very important, you can take different kinds of output action, including alert or send data to other systems to trigger another business process. ArcGIS Velocity falls into Esri's real-time visualization and analytics capability. It's in many ways a parallel product to our real-time and big data capabilities in ArcGIS Enterprise. It includes GeoEvent server capabilities for real-time data ingestion and incident detection, but also big data pattern analysis capability in the GeoAnalytics server. Enterprise GeoEvent server enables end-to-end situational awareness, analytics, and alerting for data in motion. And when data grows over time to large volumes, GeoAnalytics server comes in as the solution to process that data efficiently. ArcGIS Velocity becomes then bring these kinds of capabilities from your optional capability server, such as your geo-event server and your geo-analytics server. Bring those functionalities to the cloud environment, ArcGIS Online. So as I mentioned, it's the parallel to those products in the cloud. So it has geo-event server capabilities and it has geo-analytics server capabilities. The geo-event server capabilities for real-time incident detection, alerting, and the geo-analytics capability for big data summarization and analysis. ArcGIS Velocity provides these capabilities in a cloud environment that can scale to high velocities and balanced data. In other words, without onset of configuration and monitoring. So you can think of ArcGIS Velocity then as standing on the edge of Esri's geospatial cloud. You can connect to Internet of Things platforms and third-party APIs for sensor data. It does not typically integrate with sensor directly. So in other words, ArcGIS Velocity is not integrating directly with the sensors, but of course through APIs, Amazon Web Services, and other Internet of Things technology, it can mine those data and bring them over to ingest them into ArcGIS Velocity. So the user will directly configure feed items to receive streaming data inputs. And we also have real-time analytics on this data. Additionally, it allows users to apply real-time tools to that data and output resulting alert and action. And with the big data analytics, users can access and analyze big data repositories of historical observations. So those analytics are generally geospatial content like your stream layer, feature layer, and map image layer, which can then be leveraged through the ArcGIS platform, client apps, APIs, or desktop application to drive additional insight and situational awareness. And we will explore that in detail. The feeds and analytics are configured with the ArcGIS Velocity web application, which is a new application in ArcGIS Online. So this is basically an add-on to ArcGIS Online. Overall, ArcGIS Velocity is very much like an engine. It's a cloud system that runs real-time and big data jobs, and the application is an authoring experience for those hosted capabilities. The new item types, these feeds, real-time, and these big data analytics essentially map back to essential challenges with Internet of Things of ingesting data, alerting when incidents are detected, and doing analysis. So those feed and analytics that were discussed are configurable with Velocity web app. So as ArcGIS Velocity is much an engine, as I mentioned, the cloud system then runs real-time and big data jobs. The app is an authoring experience for those capabilities. And we do have 3 new tabs, as you can see there, for ingesting, alerting, and analyzing. Feeds, real-time analytics, and big data analytics initially map back to these 3 real-time challenges of ingestion, alerting, and analysis. Let's look briefly at this dashboard on screen and the demo that follows. As mentioned earlier, with the availability of sensor data, ArcGIS Velocity helps to view and create some of the more advanced products from data. The dashboard and the demo will follow, focusing on the transportation use case. This traffic operations dashboard has 4 different Velocity real-time feeds and 4 different business data feeds, which are being geo-enriched by some of the Velocity feeds. To the left, you can see traffic incidents across time. That's the top left of the dashboard. This is coupled with construction data, business data to get alerts of what accidents are happening in construction zones, and to see ahead of time what is happening in a construction zone and keeping that historical data over time. Below, towards the left, are weather sensors capturing temperature, humidity, and wind speed. To the right, you can see partner data, taking the static car data, counting cars within the capture zone, while collecting average speed limit, historical data for a week, a month, depending on what interval you would have set. Additionally, there is connected car data with traffic volume, etc. All right, so at this time, let's look at how to create these feeds, getting data, ingesting into the ArcGIS Velocity. Right, so for the first step in ArcGIS Velocity, what we want to do is to get to the home page, and there are different ways to create feeds. We want to pick from layers there, and what we're interested in here is the web and messaging feature with the HTTP section. Of course, you can, after selecting HTTP, we want to select none. And then go next. And we want to paste our schema, a sample of it. Velocity reads the schema to basically derive the fields that will be represented, whether some fields here are latitude, longitude, speed, journey, idea, which is a unique identifier for vehicle ignition status, which tells of the origin and destination depending on when the key is turned on or off. Those are some of the fields that would have been created. We have coordinate information, just to name a few. Of course, we want to confirm date, time fields and fill some of the other parameters. Fields there for speed, journey ID, that's important. Of course, as we want to track the movement of equipment in the field. Add XY field, fill in other parameters that we have used, date, time field. And then we want to, of course, as we create an output, other parameters we want to also add. And the tracking ID, journey ID field for that, and select next, which takes us to naming that feature. We have to, and we can't have space in it. So can you either use an underscore or just common letter, capital letters as the name of the field. We want to select our interval, how often we want our data to be updated. And since this is a lot of data that will be stored historically over time, some persons may want to choose longer intervals, maybe for a day or a week or so. Select whether we want to export data, complete the process. And so we'd have created that. And here are some lists of fields that would have also been already created that we'll be using for the next portion of the demo. Sometimes this may take a little time. So what we want to do is actually have something for the purpose of this demo in there. Have something stored to be used for this purpose. Right? And that's the first step of creating a feed. All right, so let's talk more about what feed is. What we just saw in the demo is basically the first step in leveraging sensor data, which is simply accessing and importing data in, or what we call as feed. There are thousands of sensors on the market today, and being able to connect to that data and use it often involves vendor-specific data application or requires customer-built solutions integrated with enterprise systems. Configuring a feed in Velocity is an easy-to-use guided workflow, as we saw earlier. You click, you go through as all of the underlying coding development would have already been done for ease of use. But just that first step is just being able to get feeds from wherever, whatever internet platforms, Internet of Things rather, platforms that you would have been using. Configuring that feed in Velocity is a very easy to use guided workflow, as I mentioned. It allows you to directly and seamlessly connect to external sources of observational data like Internet of Things platform, as I mentioned, message brokers or third-party APIs. They automatically derive the schema of the data and allow you to revise your data model on the fly. And you simply add them to a map and immediately see the real-time information and combine it with other data. This is both system integration and situational awareness configured in minutes without any coding. Real-time analytics. Bringing in data with feeds is just the first step of the process. With real-time analysis, you can do more than just visualize your sensor data. You can immediately put them to use. In Velocity, a feed as the input to a real-time analytic, which can be used to transform, enrich, and detect incidents. Real-time analytics are a flexible model of building capability that lets you combine tools that take different kinds of actions. There is 3 basic kinds of action that you might take. You might store sensor observation over time to a feature layer. You could choose how long you want to store data for and whether you want to keep every observation or just the most recent for each track entity. You can also send notification and alerts when particular incidents arise, and you can also send some commands and triggers to external systems to trigger behavior. Real-time analytics provides processing horsepower to your tracking and sensor workflows. So instead of requiring customer-built application that needs to be incorporated complex streaming analytical base, as we will see in the next demo, any end user can assemble an end-to-end workflow to detect incidents and capture data. And real-time analytic process each to serve us, whether through geofencing or enrichment of data. And you can combine different tools together in a workflow. As you will see in a moment, the different kinds of tools that are available to ask any number of questions and associate different output behavior within each one. So in some cases, you might want to store data, as I mentioned, whereas in other cases, you might want to, for example, send an alert or command to a third-party system. Real-time analytics are a useful way when your decision timeline is operational, when you need to know about something and act on it immediately. All right, so let's explore now how to do a real-time analytic, how to analyze the data that has been ingested in the system. So these are some of the feeds that we have there. Of course, some would have already been running in the background. And towards the right, you're able to see some of the tools that are available. You can search for content that you wish to use, whichever feed that you would have added. And from here, you build your expressions depending on the kind of output that you want. Of course, you have some 2 to 3 million points of data that are coming. So of course, you want to filter that data just to achieve the kind of output that you want within a geofenced area. We build an expression, of course, to find out where the ignition status, as we're tracking a vehicle, is equal to key is off. We want to test our track when a vehicle was turned off, just to help in measuring the start and stop, and what time it would take for equipment in the field to get to their destination, or what time it would have taken them to get to their destination. We need to filter output data. Basically here, you add your expression, as I mentioned, to say where ignition status is equal to key off, depending on the parameters that you would have set when the feed was created. So these are basically fields that were created in the feed. And some of these tools here are similar to what you would have known in ArcGIS Online. ArcGIS Pro summarize data calculations, and of course the feature to send trigger notification. While that runs, we can look at analytics that are running the dashboard. So this would take a little time to run, but we can always, in the interim, look at the one that would have, of course, been the framework for the dashboard. Set an interval and get choose whether we want to export the data or not to export it. Give it a name. Complete. And we would have created an output feature. Okay. All right, so this is basically the framework for what we were looking at with the feed, the dashboard. This was what contributed to the building of the dashboard. This model that we're seeing here with all the calculation tools. We're looking at points, trying to measure, pulling in traffic feed data in real time with filter by accident or jam. For each point captured, of course, we want to create a buffer to connect construction data. The output of merging the data is a construction alert. So towards the right, bottom right, you'll notice there is the option there, the tool to send a message, just in case in this demo, if there is a possible snow or ice event. So what we really want to trigger is to send out a message to customers. If the wind speed that we got from the feed is above a certain amount, and if there is precipitation at the same time, we triggered a feed to notify our customers or users of that particular buffer roadway that there may possibly be an ice event. So they should be on the lookout or be careful, or in other words, explore other route options. The output of this feature service is to tell the weather, as I mentioned. Also, there's an expression to provide notification, as I mentioned here, of a possible event. So if you look, you see an envelope icon that's based on the precipitation. If there's precipitation coming in from the weather feed and wind speed, as I mentioned, above a certain level, then a notification will be triggered from that filter to say there's a possible ice event. The number of cars also counted. So simply, it also helps you based on the speed at which cars are moving and the numbers counted to know if there is possible traffic. And another notification, of course, will be triggered depending if you would have set this in the back end as well. We can then further see how some of this data that was collected for big data analytics can be used to create information products and take this even a step further. All right, so let's look at some input and output types. What are some of these input and output types? So velocity supports those kinds of patterns because they are focused on integration with external systems. As I said, velocity does not directly communicate with these systems, but communicate with them through Internet of Things platform. There is extensive support for different real-time and big data systems and various data formats. They are aimed at covering major commercial Internet of Things platforms as well as common real-time messaging technologies. So those are our approach, especially for real-time scenarios, is to also help you to make your data usable in ArcGIS. So whatever information products would have been created in ArcGIS Velocity can also be used in other ArcGIS applications, your ArcGIS Pro, ArcGIS Online, as was mentioned. So in other words, the data can be used in these systems. You can also, on detecting incidents or finding particular patterns in this data further in other ArcGIS applications. Now let us discuss some feed data source. For example, MQTT, I've already highlighted some of these, can be used as a bridge to bring in a vehicle tracking data from vendor like JILJAB and Azure or Amazon Web Services, Internet of Things Hub, could be leveraged to access data for SCADA system and make it available externally. Polling a website enables you to access any number of sensors, vendor API. So once you have these, then you have feeds coming from vendors or partners that you would have been affiliated with, you can make meaningful use of these data. As we continue to explore the transportation use case, beyond real-time visualization and analysis, you can also work with data that you store over time. Feeds bring in and visualize real-time data, and these data get used in real-time analytics for immediate awareness of incidents. Real-time analytics, of course, can store observations over time to a feature layer. As data arrives in real time, your historical data set can grow to large volumes extremely quickly. For example, let's say 100 messages per second can grow to million records in one day. Therefore, for that reason, ArcGIS Velocity is designed to grow with you. I would have mentioned that earlier as well. It includes fully configurable big data analytics, so you can process this information for trends, and these big data analytics can be traditionally run ad hoc analysis, but they can also be scheduled and run in near real time to support different kinds of workflows. For the next demo, we will learn how to create a big data analytic. Just to recap, the feed was created, then real-time analytic, which provides output. We also saw a historic component, so you would have a big chunk of data and the big data analytic functionality. Here are some statistics which include running the analytic, how many successful runs would have been there. But however, let us look, as I mentioned, one was already being run in the background just ahead of time. One of the features is that this was scheduled. You can schedule to run, say for once per week. At the top, you see these alternative fuel stations in the demo. So let's continue scheduling first. Whether you want it to run once periodically or recurring runs at a time, concurrent time. And there's the feature service at the top, as I mentioned, for the fueling station. And this is in case in the transportation sector for electric vehicle infrastructure. Now, the fueling stations are brought into the analytic. And then you will have to, of course, filter by state. So you're doing a buffer for about 1.25 miles here to look at what is going on around the stations. Pulling, of course, from the connected car feeds that we saw in the dashboard, from sensor data in the roadways. 2 million points basically are coming into the tool to construct the tracks. But what we want is just to do like a subset of this within a particular environment. And that's why we have the 1.25 rather miles buffer. We can use this tool to reconstruct the track of the vehicle, providing us with where it went based on and also average speed, where it started and where it ended, based on the feeds that would have come in terms of ignition, when it was turned off, every time depending on the sensor in the vehicle, when the keys of the car would have turned on or turned off. That data can be harvested to kind of establish the amount of time it basically took to cover that track. The buffer has 128 features, really. From the connected car data, we use the managed data tool to calculate the distance of the trip and create a linear output. At the very bottom, of course, we brought in living Atlas track to achieve this outcome. So we have here trip length, we filter by key event. Of course, as I mentioned, based on the ignition sensors, we want to create that buffer route and have an output feature class for the trip length, the trip time as well. So this is just a little of what could be done. And of course, once finished, we hit start and allow it to run to produce what we see in the dashboard.
Of a buffer area of about created one already that.
Big data analytics. So those big data analytics are parallelized through Spark to get large jobs done quickly. And as you saw, they're put together a virtual programming model building experience. So no coding is necessary. You can visualize data in ArcGIS there as shown in the video, or pulling data from a cloud store like Amazon S3 or Zero Blob. So results certainly can be sent to ArcGIS layer for visualization. But Velocity is also an Internet of Things oriented system. So you can also configure a big data analytic to aim a result to an external destination. And also big data analytics so you can store over time. Your organization does not have to configure and maintain on-premises. In this case, as I mentioned, it would have been done in the cloud environment. You can run analysis either only on feature layer with data, perhaps over time in the cloud, big data store that for those fleet is just another way of looking at the system, the organization of the system. So much like real-time analytics, you can see each different tool basically working together as a part of a system. So it's a very integrated system. So then you can ultimately trigger a notification and take an action based on the overall system status. Additionally, big data analytics are very useful when your decision timeline are tactical. When you need to make a decision regularly based on a standard practice or strategic way, we need to learn over time and adjust larger approaches. There's a wide variety of spatial temporal analysis tools, including ArcGIS Velocity. And as you can see here on screen, some of these, many of our customers online here would have been familiar with some of these tools within ArcGIS Pro, etc., are also there in ArcGIS Velocity to accomplish the big data analytics. There are largely the same tools available in the GeoAnalytics server today, but it also includes tools and concepts from GeoEvent server that focus on tracking and movement analysis, like calculation of motion statistics, summarizing journey and trip information, and snapping tracks to road network. All of these tools can be used in big data analytics, and those that operate on a single message at a time can also work in real-time analysis. Both types of analytics in ArcGIS Velocity can generate output feature layers from visualization of time-enabled data. And there are 3 different types, some of which would have, of course, we'd have mentioned these per. First of which is your stream layer. Stream layer visualizes new data as it arrives. And feed is also a type of stream layer. So we're looking at a city bus moving around on their routes. City buses moving around on their routes, rather. Stream layer are based on a WebSocket technology that the map is continuously connected to an underlying real-time server. So as these feeds come in, of course, this is a part of the stream layer. There's also feature layer, which many here will be familiar with based on the work you'd have been doing in your ArcGIS Pro, ArcGIS Online. Feature layer visualize data only once it is being stored. And this is the most common layer used in the ArcGIS platform. So to visualize data from feature layer in near real time, you can set a refresh interval so that you can record information every few seconds. Similarly to what is done in ArcGIS Online, you set an interval once you're collecting real-time data. And the third and final is the map image layer. It creates a special kind of map image layer. So this one actually supports dynamic aggregation of high volume data so that you don't have to, for example, draw millions of features individually. This on-the-fly aggregation refined continuously as you pan and zoom in the interface. So all of those three layers can be created through the analysis task and using dashboards and apps to visualize this information and improve situational awareness. Just a brief notes on licensing. ArcGIS Velocity, many would have the question, what are the different kinds of licensing available? Here's this slide to address that. It's an annual subscription, firstly to highlight, sitting on top of ArcGIS Online. ArcGIS Velocity is licensed as shown in 3 tiers: the standard level, or tier rather, the advanced tier, and the dedicated tier. With your standard licensing level, there is a limitation on the number of features per second that you can ingest into the interface, as well as the number of feeds and analytics that you can run at any one time. And then that limit is increased with the advanced level. And then basically those limits are largely removed with persons who will select the dedicated level. As I mentioned, it sits on top of ArcGIS Online, so it works with your user types that some of you would have been familiar with. It's managed as a web application within the ArcGIS Online environment, and it's authored in ArcGIS Online. This web app is available to any creator or GIS professional in the organization. In other words, from creator to GIS professional with a basic, standard, or advanced, depending on, it has to be, however, as I mentioned, the standard member levels, creator professional. Now, these analytics are authored in ArcGIS Velocity and run in an automated way, can generate different types of information products, as we mentioned, the stream layers, the feature layers, map image layers, and the creator user type are the ones that, of course, would manage the creation of these products. The other member levels, viewer to field worker, are connected to that organization, so would have access to whatever products would have information products that would have been created. But those who will author the task, of course, would have to be one of the standard level as shown on screen. Just to wrap up by reiterating that ArcGIS Velocity is configurable, real-time, and big data analytic engine for ArcGIS. In summary, what you can take away from this is basically some of those functionalities that you would have in ArcGIS Enterprise have been also transferred to ArcGIS Online in the cloud environment for those who may not have the enterprise technology within the on-premise and are working in online, can always have some of these functionality through ArcGIS Velocity. That's the big data functionality and also the geo-event functionality of getting real-time data and also putting that data to use. This involves 3 steps as shown. The first of which is to ingest the sensor data with wide support from different messaging systems, data format, and data velocity. The second is to automate analytical process of the data, whether in real time or in near real time, with scheduling or with massive amounts of data over time. And finally, to drive specific actions from analytical results, such as alerting. You want to be able to do something with the data that you have analyzed, to trigger a response or to command another system to take action. This is also configurable with familiar, powerful spatial analytic two analytical tools that were shown before. These steps can be applied to use cases such as personal tracking, asset monitoring, and infrastructure protection. Here are some resources that you can further explore to get additional information. Of course, if you can do a screenshot of the screen, or we'll be uploading this to our Spatial Innovation Limited YouTube channel, to which I'm going to hand over at this time. As we'll take your question and answer, I'm going to hand back over to our Vice President, Corporate Services Business Unit, Ms. Tanya Manasai. Thank you so much for the presentation.
All right, thank you, Lina. At this time, we're open for questions. I will wait, Lina, so it was really a very eye-opening presentation, so thank you. Well, one of the things that came to me, oh, we have a question, let me see. Will ArcGIS Velocity be available in ArcGIS Enterprise in the long term? And will it eventually replace ArcGIS GeoEvent or Analytics Server?
All right, so thank you for that question. It's a very good question. So will ArcGIS Velocity be available in ArcGIS Enterprise in the long term? As it is right now, ArcGIS Velocity is an add-on to ArcGIS Online. There are developments right now to have it in ArcGIS Enterprise as well, but it has not been materialized as yet. And to the second part of your question, will it eventually replace ArcGIS GeoEvent Analytics Server? No, it's not to replace those functionalities within Enterprise, but to also share those functionalities from Enterprise with the ArcGIS Online cloud environment.
All right, well, thank you. We have another question from Dave Williams. How would the solution be deployed? Does Esri assist with the implementation, or do they use partners?
Thank you for that question. All right, so how would the solution be deployed? So one of the things that I want to mention as an advantage, this is not like the Enterprise where you have to download, install, configure, and of course we may need some professional services to get that done. This, once you would have purchased within about some 30 minutes, the add-on would appear in ArcGIS Online, so there's no configuration that to be done in that case.
So you're saying there's just immediate access almost?
Right.
To this product. Okay. You can keep your questions coming. Can you go back over what are some of the applications that come with ArcGIS Velocity? Like what? That one I remember you talking about feeds, and so you could go back through those things to try and trigger.
Okay.
Yeah.
All right. ArcGIS Velocity includes an application that allows users to create like feeds, as you mentioned, real-time data ingestion and visualization. Not just that, persons want to do more than just visualize data. They also want to be able to use the functionality of big data analytics, to be able to process that data, similar to what we mentioned would have been possible with your geoanalytics server capabilities in Enterprise being brought over here. Also, there is the feature and map layers functionality where you want to work with high volume data visualization and the on-the-fly aggregation portion. finally, as I mentioned, things like stream layers, these kinds of feeds coming in at high velocity, live as persons update their work in the field. So those are some of the what's included in velocity.
All right, thank you. Can you explain a little bit more about how ArcGIS Velocity works with ArcGIS field maps?
Thanks, Tanya. That's a very good question, since ArcGIS field maps is a lot of customers are using that now for field applications. So I really appreciate that question. ArcGIS Velocity allows you to basically connect to streaming or collected data sources from a variety of systems, as we would have shown in the slide. Internet of Things platform for analysis and visualization. ArcGIS Field Map, as I mentioned, is a mobile solution that gives you that field mobility capability that allows you to capture the locations of mobile users, monitor where they are, and analyze where they've been. What Velocity does is that it can be used to perform real-time or batch analysis on this data that you're collecting in the field, such as things like geofencing, employee locations against work assignments, reconstructing employee tracks, and assessing coverage of operational areas. To work with data from field maps, configure a feed or data source to read from one of your organization's track views.
All right, thank you, Lionel. We know that accessing velocity is almost immediate. You said within 30 minutes or so, once we have our subscription. But how do we go about getting the subscription and purchasing ArcGIS Velocity?
All customers within our distributorship, that's within the English-speaking Caribbean, can contact Spatial Innovision Limited for access to ArcGIS Velocity. My email is on screen on this question and answer page. You can always go ahead, or at the end of the presentation, reach out to us, and we provide you with a formal proposal on how to acquire the licenses. And this is, of course, a subscription license.
All right, thank you. But are there opportunities for us to, try out the product before we commit?
That's a very good question. I'm sure there are many others online who want to know, of course. Can I test? Can I evaluate? Can I see what the product is about?
Yeah.
And I want to say, of course, when it comes down to licensing, Spatial Innovision Limited, depending on conditions apply, will assess what is it the customer would want to accomplish, and have a talk with the account managers here at Spatial Innovision Limited. So once customers reach out to us, they'll be directed to an account manager who will basically handle the process of acquiring an evaluation license. Evaluation license can last up to even 90 days.
Okay.
And persons can get to test out. Of course, the evaluation license is for the standard. So you will, it's not dedicated, but you will still get majority of the functionalities to see what it's about.
Right. But we do get help with the setup. We can get some help with setting up our parameters and same back end things that you showed us. If we don't have, if a firm doesn't have everybody on board to do that kind of setup, Spatial will accommodate that kind of assistance.
Thank you so much for that question again. I want to say firstly that, as I mentioned, in terms of acquiring the product, once purchased, it will be available to the customer immediately.
Okay.
There will be no need for configuration of the system. And secondly, if understanding of how to use the technology and how to create these information products, how to get the feeds into the system, how to do the heavy duty analysis workflows, if that is needed, I am pleased once again to mention that within the customer empowerment business unit, we have ESRI certified trainers who are able to walk you through comfortably on how to use the product.
All right. Thank you, Lionel. Are there any other questions? All right. Not seeing any questions coming through, so this is where we have to leave our discussion at this time. Thank you very much, Lionel, for a very informative presentation. Lionel has shared his contact details on his final slide, and he's looking forward to hearing from you. Please access the recording of this and previous Spatial monthly webinars from the Spatial YouTube channel. Thank you for joining us today, and we hope that you will continue to join us throughout this year at our next scheduled Spatial monthly webinar. See you then. Have a great day, everyone. Bye.